Good morning and welcome to our 1-7 talking about more properties of integer exponents. Today we're going to focus on two major things. One is the zero exponent property and the other is going to be the negative exponent property. If you have my class and you have the notes, you're going to want to turn to the page where it says 1-7 and you might have to pause the video to copy some stuff down. So the first thing we're going to talk about is the zero exponent. So there's a property called zero exponent property that states this, that anything to the zero power equals 1 as long as that number here, whatever it is not 0. This says not equal to. And here's why this works, right? So if you have any number over itself, it equals 1, right? So like 8 over 8 there, that's what that says. That's equal to 1. This is the same for anything with an exponent. So what we've learned in the past is that if you have a fraction and you have the same base, like 2 to the third over 2 to the third, right? And let's write that bigger so you can see. So 2 to the third over 2 to the third, we've learned that you can keep that same base of 2 and you can subtract the exponents. 3 minus 3 would give you 0. But really that has the same numerator and the same denominator there. So we know just like 8 over 8 being 1, same numerator, same denominator is also still 1. Okay? And so we don't really use 0 as an exponent. We simplify that to be just one whole, okay, is what that means. Okay, so anything to the 0 power is one whole is what that means. So even if you have a negative number, this says negative 7 to the 0 power, and we have parentheses in there, negative 7 to the 0 power, it's still equal to one whole. Okay, this next one says in parentheses 43 to the 0 power, still equal to one whole. The next one here says 1 to the 0 power equal to one whole. The next one says 0.5 to the 0 power, still one whole. They're all equal to one whole. Anything to the 0 power is equal to one whole. Okay, now where it gets a little more complicated is when you have something under here. So it says, convince me, y is 2 times, so this is times because there's nothing between the 2 and the parentheses, 7 to the 0 power equal to 2. Well, if we replace that 7 to the 0 power now with what we know that it is equal to, it's one whole, right? This is really 2 times, oops, I'm sorry, let me get a different color here. This is really 2. If I replace that with a 1, which I know is one whole, equal to, well, this is really 2 times 1 equal 2. That's why, because anything times 1 is equal to 2. By the multiplication power of identity. So this always works. 2 times 1 equal 2. Okay, the next thing that we need to talk about today is what we do with negative exponents. So far in our lessons, we've left them negative and left them alone. However, the idea is to not have negative exponents at all. So the negative exponent property says that anything with a negative exponent, a base of a negative exponent, to get rid of that negative exponent, you put it in a fraction, and you would put 1 over that base with the exponent, and that gets rid of the negative, okay? So let me give you an example. If, for example, I had, let's say, 5 to the negative 2 power, right? The way we would get rid of that negative exponent is by making a fraction, and we're going to put that base of 5 at the denominator of the fraction, and we're going to get rid of that negative 2 and replace it with a positive 2. And then you can't have a fraction without a numerator, so that's going to be 1. All right? And then what we're going to do is we're going to simplify that even further. We know 5 squared is really 5 times 5, right? So this is really 1 over 25 is going to be our final answer. If we're just going to leave it with exponents, it would just be 1 over 5 squared. These are both correct. This is with exponents. This is fully simplified. Okay, let's do an example of it. So, um, if you have 4 to the third divided by 4 to the fifth, we've learned already that division here, right, looks like a fraction. We can rewrite that as 4 to the third over 4 to the fifth. We've also learned that if we have the same base, we're going to keep that base of 4. And fraction, we're going to subtract our exponent. So 3 minus 5 gives us negative 2. Now, instead of leaving it like that, what we're going to do is go one more step with it, possibly two, depending on if we want to leave it with exponents. And we're going to make this a fraction. We're going to take the base of 4 and put it in the denominator, and we're going to leave its exponent as a 2, but we're going to make it positive now since it's in the denominator, and we're going to put the numerator as a 1. Now, this is simplified. If we want to leave it with exponents, this would be our answer, is 1 over 4 squared. So this could be a possible answer. Now, if we want to go one more step and simplify it further, we would leave that 1 and we would simplify 4 squared, which we know is 4 times 4. And so our final answer is fully simplified would be 1 over 16. Now, something that I want to show you, just so that you can see that these are equivalent. If I have a calculator, all right, and it does exponents, 4, if I do 4 and I raise it to the negative 2 power, like this in a calculator, I get this decimal, 0.0625. So in a calculator, the decimal is 0.0625. Let's see what the fraction of 1 over 16 is. So 1 divided by 16 gives me that same exact decimal. And so this is just showing you that as a decimal, these are also equivalent. And something I want to point out is that a negative exponent does not mean it's a negative number necessarily. A negative exponent means that it is a very small number. So this is a very small amount. It's going to put it in a fraction. Okay. Let's do one more. So we're actually going to skip down right now. We're going to skip the try it for the video. And we're going to skip down to the last example, example 3. So example 3, oh, let me write that even bigger. I tried to write it bigger, but we need it even bigger for our video. So it says, write the expression 1 over 7 to the negative 3 power with a positive exponent. So something to note is that this works in reverse as well. So up here, right, when we had our negative exponent, what we would do is we would put it in a fraction and make it a positive. Well, we can go in reverse. So if it's already in a fraction, right, what we do is we do the reciprocal to get that positive. So a reciprocal is a flipped fraction. So let's go ahead and write that down. Reciprocal is a flipped or an inverse fraction. For example, a quick example, the reciprocal, I'm sorry, can't see that either. All right. The reciprocal of 3/4 is 4/3. Those are reciprocals, okay? Now, in this case, to get rid of a negative exponent that is already in a fraction, we flip it to its reciprocal. So the reciprocal of that would be 7, and when we flip that, we get to get rid of the negative exponent. It would be 7 to the third power over 1. And something to note is that anything over 1 dividing by 1 really keeps it the same. So this is equal to 7 to the third power. Okay, so it works both ways. You can get rid of a negative exponent by putting it in the denominator of a fraction if it's not in a fraction to begin with, or you can use the reciprocal if it's already there. All right, if you have me for class, our assignment today is out of your book. Our homework is out of your book. So you will need the book and the page that it starts on. It's going to go from pages 50 to 52, and we're going to do numbers 1 through 19 in that book. Okay, If you have any questions, please make sure you come see me or email me, and I will get back to you as soon as possible. Have a great day.